Have you wondered how we know what the structures of organic molecules really are? These molecules are much, much too small to see. How can we tell their structures? Well, in today's world, there are a set of instruments that let us determine specific information about the molecules that collectively will let us assign structures to organic compounds with great confidence. Take a look at this simple example. You know that if we treat an alkene with a variety of reagents, we can add water to the double bond. And that water might be added in a way that we call Markovnikov addition, the OH on the more substituted carbon, or that water might be added so the hydroxyl group ends up on the less substituted carbon, as in this product. How do we know which is which? You'll see that using the instrumental techniques described in these lectures, we can determine structures with great confidence, and we can know for certain whether we made the secondary alcohol or the primary alcohol in the example above. The first lecture will give you an overview of the 5 techniques and how they might be applied in combination to make structure assignments. Following that, I'll describe mass spectrometry, often called MS, which reports the weights of molecules and the weights of pieces. This can be very powerful information. In the next lecture, I'll talk about infrared spectroscopy, often called IR, which looks directly at functional groups and will tell you which functional groups are likely present or often absent from molecules. Very important. In the next lecture, we'll talk about a technique called UV-Vis, UV visible spectroscopy, which looks directly at double bonds, pi systems, often conjugated pi systems, and that can be very powerful information, but is more limited in scope. Carbon nuclear magnetic resonance, often called carbon NMR, looks directly at the carbon atoms in a molecule and will tell you something about atoms that are next to those, for instance, functional groups. So we'll get some very important information because all organic molecules have carbon atoms, and functional groups and how they relate to the carbon atoms of the molecule is very important information. And lastly, and perhaps the most powerful, proton nuclear magnetic resonance looks directly at all the hydrogen atoms and gives you a wealth of information about the hydrogens in a molecule and where they are relative to each other and functional groups. Putting these techniques together and using 1, 2, 3, maybe all of them, lets us assign with great confidence the structures of organic compounds.